Welcome, dear audience, to my presentation about a demo paper named SparCAssist, a model risk assessment assistant based on the Sparse Generated Counterfactuals. I'm Zhang Zijian, a PhD student from the Leibniz Universität Hanover in Germany. Nowadays, apart from the performance of the machine learning model, we're also interested in how the machine learning models make the predictions. But we are troubled by the complex models and always treat them as black boxes. But thankfully, we as human beings are also good at learning from counterfactuals. We are easily to get the insight into model's behavior pattern by comparing its different output under the counterfactual inputs. The counterfactual inputs are a bunch of what-if questions. What would a sentiment classification model predict if I input I hate this movie instead of I love this movie? In our approach, we define the counterfactuals as depicted by this diagram. In the feature space of the black box model, the curve B, machine, and the B, human, represents the model's decision boundary and the optimal decision boundary that concord with the human annotators respectively. The red dot X represents the factual data the model is well trained on. For instance, a movie review, I love this movie. The xc1 and xc2 are two counterfactuals of x that stays in the vicinity of x with respect to an adequate similarity metric. The model predicts x, I love this movie, from the training data correctly. The model can even predict I hate this movie correctly if the model learns this semantic well. But the model would fail given the counterfactual I love this film, simply because there is a biased correlation between the word film and the negative label in the training data. Here, the model's prediction is dissonant with human ground truth. To generate such interesting counterfactuals from X, we at first mask all of the words that are not helpful for the prediction from the input X. Then we attribute prediction scores to each rational word according to the prediction model. Then replace the word with the highest score with another word, so that the new prediction goes towards another class. This procedure then starts from the position attribution over repeatedly until the prediction flips. We use hot flip and masked language model for generating words replacement candidates. This is what our system looks like. In area 0, a user could upload her own model on datasets, or she can use our prediction model and our movie review sentiment classification dataset by default. Then for each document from the dataset, the user can choose a sentence to focus on in area 1. Because the input documents are usually wordy and easily lose focus, it is better to select one sentence only and focus on it. Then the user can evaluate the counterfactual generated with the default mask attribution replacement strategy at area 2. It is also possible to intervene the word selection by specifying the word replacement in this area. She can then decide whether to evaluate and save this generation or try another word masking replacement strategy. The user can also custom her own word masking until an ideal counterfactual is found. That's all for the presentation. Thank you for all your attention, and I'm looking forward to talk with you at the conference.